In this short video, I present a paper titled The Versatile Photothermal Behavior of 2-hydroxyazobenzene, which is a fruit of a collaboration between my group working at the Department of Chemistry, Biology and Biotechnology of the University of Perugia in Italy, and the Institute of Chemical Sciences and Technologies Giulio Natta of CNR in Perugia. The 2-hydroxyazobenzene and its conjugated base are two photochromic compounds. UV irradiation promotes trans-2-cis photoisomerization, accompanied by the spectral changes shown in these two figures. The isomerization is thermally reversible at room temperature. If the UV radiation is discontinued, the cis isomers revert to the trans forms thermally. The spectral and kinetic properties of the two photochromic compounds have been characterized in three different media: in acetonitrile, in water and acetonitrile mixed in a 1:1 volume ratio, and in an aqueous micellar solutions of this zwitterionic surfactant. Both molecules have shown photochemical and chemical kinetics sensitive to the microenvironmental features. The protonated form has exhibited the most significant photochemical quantum yield and the fastest thermal cis-to-trans reaction in acetonitrile. The tight microenvironment generated by the micelles determine the lowest quantum yield for the trans-to-cis photochemical reaction and the slowest cis-to-trans thermal reaction. The deprotonation of the 2-hydroxyazobenzene provokes dramatic changes in its photochromic properties. The conjugated base has shown larger photochemical quantum yields in the three media. In particular, the best medium to promote the photochemical trans-to-cis transformation has been the water acetonitrile mixture, whereas the worst has been again the aqueous solutions of micelles. The absence of a proton makes the cis-azobenzene extremely lazy in isomerizing to the trans thermally. Nevertheless, the fastest recovery was detected in water acetonitrile mixture. It took almost 10 hours, whereas the slowest one was in the micellar solution. It took nearly 23 days. Clearly, the 2-hydroxyazobenzene and its conjugated base are valuable probes of microenvironments. As probes, they have been characterized by two parameters. The first parameter is colorability. Its definition has its roots in the theory of information formulated by the engineer Claude Shannon. The colorability, which is definable for any chromogenic compounds that can switch between two forms, A and B, is the difference between the information sent by B and that sent by A to the human eyes of the observer, who is sensitive to visible light. The colorability of the 2-hydroxyazobenzene decreases by photoisomerizing from trans to cis and increases after deprotonation. The second parameter is fuzzy entropy. It quantifies the degree of microheterogeneity of any chemical sample. We fitted the thermal cis-to-trans kinetics in the three media through polyexponential functions. The maximum entropy method allows determining the least number of exponential terms required to fit the kinetics. These figures shows the distributions of the cis lifetimes in the three media. The shape of these distributions is related to the microheterogeneity. The broader the distribution, the stronger the microheterogeneity, and the larger the fuzzy entropy value. The largest value was obtained in the mixed solvent. The smallest one was impure acetonitrile, as expected. Finally, the 2-hydroxyazobenzene is a photoacid. Under irradiation, the trans isomer transforms into the cheese. It becomes a stronger acid because the intramolecular hydrogen bond involving the hydroxylic group is broken. Therefore, we record a photoinduced pH decrease, and the pH variation is reversible due to the thermal cis-2-trans isomerization. The 2-hydroxyazobenzene can contribute to the development of neuromorphic engineering because it can mimic neurons in phasic dynamical regime. They respond in an analog manner to external stimuli, like our photoacid. Moreover, the 2-hydroxyazobenzene can communicate with other molecules through the light it transmits and the proton it can photorelease. Thank you for watching this video, and if you want to know more details, I invite you to read our paper by clicking the link in the description below.